I'd like you to imagine two identical farms with two identical fields of luscious red strawberries. Both farms are certified organic, irrigate with sprinklers, and pay bearded environmental studies major 20-somethings to sell their produce at farmers markets. The important difference, however, is that Field A emits twice the amount of the 3 major greenhouse gases as Field B. In order to reduce emissions that contribute to climate change while providing consumers the same healthy produce, I plan to investigate how to optimize compost application rate with a field and complementary laboratory experiment. But first, what is compost? It's decomposed organic matter, such as plant litter and animal manure, providing critical elements like carbon and nitrogen to plants and improving soil structure. While there's a great deal of information about synthetic fertilizer application in conventional agriculture, there's little information on comparable dynamics within organic systems. And there's a tendency amongst organic growers to over-apply compost just to be safe. In 2008, there were 470,000 acres of organic cropland in California, roughly 20 times the size of Santa Barbara. As organic agriculture continues to expand, there's increasing need to quantify emissions from organic practices as well. And as an added benefit, efficient nutrient application minimizes agricultural runoff into our recreational and even provisional waterways. I plan to study 2 fields on 1 farm that differ only in amount of compost applied. I will place flux chambers on each field and periodically extract air samples to measure their greenhouse gas concentrations in the lab. I will also measure yield from each field and compute an estimate of yield-scaled emissions. I believe that we will identify a rate of application after which there's little marginal increase in yield, but large increases in greenhouse gas emissions. Now, if you've taken economics, this should sound like the law of diminishing returns. To compare, we can think of the units of happiness you derive through cookie consumption. Similarly, plants cannot continue to happily use compost indefinitely. In the lab experiment, I will measure emissions from 5 application rates. For both studies, I will characterize the soil and compost for specific chemical, physical, and biological properties and monitor the changes to determine which variables have the greatest impact on greenhouse gas release. Upon completion of the study, I hope this data can be used to parameterize models of organic systems that are applicable under different field and climate conditions, and as a step toward including agriculture into climate change mitigation policy, whereby farmers are provided incentive for reducing emissions of gases that are quickly altering our atmosphere and threatening our livelihoods. Thank you.